I wanted to start off by a brief review of that classic of the straw bale construction literature, which you're all fairly familiar with, I think. Let me see what, okay. Pig leaves home, pig buys straw, pig builds house, wolf blows down house, eats pig. The moral of the story is not that you shouldn't build your house out of straw. The moral is you shouldn't let a pig build your house. I'm not sure what your perspective on straw bale construction is, but hopefully we'll manage to change that a little, one way or another, in the course of the evening. We'd like to make the distinction between hay and straw. David has talked a little bit about that. The early Nebraska structures were hay bale. They were meadow hay. Hay is cut green. It's cut with the seed heads on. It's meant to be a nutritious product that is fed to animals. And it's generally expensive because, indeed, it has that nutritive value. Straw, on the other hand, is the dry dead stems. It's usually, at least, what we mean by it in the United States when we talk about straw. It's generally the dry dead stems of the cereal grains. Wheat, oats, rice, barley, rye. It can also, in some, like in Oregon, it can be grass seed straw after they've harvested the seed for rye or fescue. They have straw. Bermuda straw, again, they're growing Bermuda grass seed. But usually it's the tubular stems of the cereal grains. And this is what happens to a great deal of it, still in this country and certainly in Mexico, where this was taken by Goldstein. There's a lot of it out there. By a calculation I did based on 1988 figures, 10 years ago now, at that time, if you put all the acreage of straw together in one place, brought it all in from all the states, and clumped it together, it would have been an area in those 5 grains the size of the state of Nevada. So you can imagine the whole state of Nevada planted in wheat, oats, rice, barley, and rye. If you had baled all the straw available from a field the size of the state of Nevada, it would have been enough to build about 5 million 2,000 square foot homes with 8-foot high walls. So not to worry about this becoming popular and being a scarce material. There are 2 basic approaches to straw bale construction, with a third one sort of being a hybrid that combines the 2 of them. David has up there on the board, over there on the left-hand side of the screen, the first 2, infill and wrap, are ways of doing this non-load-bearing straw bale. You create some kind of frame, timber, poles, metal, concrete block. You create some vertical elements, and you create some kind of a beam across the top that support your roof rafters or trusses. And then you either infill, as in some cases that David showed, infill between the posts, or you do, as in this case, a wrap, a continuous wrap of bales around that frame. Sometimes the bales are notched so that the posts are tucked in and aren't exposed. Sometimes they're left, as in this case, exposed. David mentioned that occasionally a 2x4 frame structure gets wrapped with bales. This was a 3,800 square foot structure that we wrapped in a couple of days. Not my favorite way to do straw bale construction. It seems crazy to build one structure out of wood and then add another structure on the outside of it. if you can do a building that can, a straw bale building that can carry the load and be structural, why build two structures? But this guy didn't want to, fight the code people and just thought, well, hell, 2x4 frame construction, easy to get a permit for it, they aren't going to give me any hassle, and that turned out to be the case. This is an example of the other way, the load-bearing way to do it. So you're not creating any kind of frame that's going to hold your roof up. You're stacking the bales, putting some kind of an assembly up there. Generically, we're calling it a roof-bearing assembly. And that assembly carries the roof on it and transferred, and that load is then just transferred to the bales themselves. In some cases, there are structures. I don't know that we've got one in here, but we could do a sketch on the board. Structures which involve some walls that are load-bearing and some that are non-load-bearing. And you can do that hybrid kind of a design. You don't want to have a mix of load-bearing and non-load-bearing in the same wall, for example. You don't want to have just posts at the corners and then have no posts in the middle of the wall. I saw one in Nebraska that had been built that way. Of course, at the corners, the bales did not compress. And in the middle of the wall, they did compress. So the roof line ended up looking like that. And so that's a mix you don't want to do. In a given wall, it wants to either be truly, framework that's carrying the roof, or you want to have it strictly bales that are carrying the weight.
But do you use that for differentiating exterior and interior walls, or do you use bales for the interior walls also? Which are kind of large, like a 38.
Bales certainly have been used occasionally for interior walls. And there's one structure in Mexico that even used bales as the interior wall, carrying it was a cathedral roof, so you had the two exterior walls carrying the outside of the roof, and where the rafters came up and met at the top, there was an interior wall of bales that went all the way up. And so it was not only an interior partition wall, but it was a load-bearing straw bale wall as well. But the disadvantage, of course, of bale interior walls is that they do take up, even on edge, they take up a minimum of 14 inches of space. An advantage is they give you wonderful sound insulation between rooms. So, it's a toss-up. The next sequence of slides is going to be going through the process of building a load-bearing straw bale structure. This is one type of foundation, certainly, that has been used. It's crucial, as with any structure, that you have a good foundation. You're going to put a lot of money, a lot of effort into building what goes on top of it. So it's important to think about how much insurance you want in that foundation. You may choose to do a very low-tech, cheap, simple foundation, but if you do, be sure that you go into it knowing what risks you're taking. You may still decide, what the hell, this is a small, more or less temporary building, I'm willing to take the chances. But with a 3,000 square foot house, I hope you won't build a 3,000 square foot house, actually. You don't need 3,000 square feet. But let's say a 1,500 square foot house, you're going to put a lot of time and money into that. So you may want to go with a lot of insurance in your foundation. This was poured as one pour. It is a slab, a toe-up, to make sure that the bales are raised off the floor level on the interior should this floor ever flood. And then it actually goes down 12 inches below the soil level here. It's a toe-down slab. It's a monolithic pour. There are a number of terms that are used. And you don't need to create the toe-up at the same time, but we highly recommend now, because of some tragic lessons that were learned, that you do have a toe-up. Get your bales at least 1.5 inches up off your final floor level, so that if you break a pipe, or if a sink gets plugged and it's dripping and you're gone and for a week and it overflows, as happened to me once, your bales are going to stay dry. This looks like somebody buried in the concrete, but it is not. It's just a glove over a rebar.
When you said that the monolithic pour, do you mean the footing below that slab?
I meant that in one pour, they created the slab, the toe-down footing, and this toe-up. It was formed such that they can pour the whole thing all at once. Depending on what kind of system you're going to be using for tie-downs, for tying the roof-bearing assembly down to the foundation, you will probably have some gadgetry in here. You'll have these embalers probably, that the first course of bales gets pushed down on, and you may have eye bolts, or you may have a tube that you're going to push a piece of polyethylene strap that will go up over and come back down. You have to think about all that kind of stuff. Anything that you are going to want to have in the concrete, get it in while the concrete is wet. Plan ahead. You will play hell trying to get something into concrete after it is cured, and you think, gee, I forgot to put, my such and such in there. Drilling and epoxying bolts in and that kind of stuff is a real pain in the butt. So do very careful planning on your foundation, so when you pour, if you're pouring concrete, you get into it while it's good and wet, whatever it is you need that you want in there. That's obviously not the only kind of foundation. Here's a collar type foundation where they didn't pour the slab at the same time. They dug a trench and poured concrete, probably went down 12 inches or so, and came up. A disadvantage of that is you're putting a lot of concrete below grade. Concrete runs about, depending on where you are, $50 to $60 a yard, maybe delivered. And so that people have looked at ways of trying to decrease the amount of concrete. You've got to have a wide footprint, 23 inches wide in the case of these 3-string bales. You've got to have that wide footprint, but there may be ways to not have that width of concrete going all the way down to the required depth for the frost line. We generally waterproof the top of the foundation in some way or other. Concrete, although we think of it as a waterproof material, will wick moisture. It's water resistant in the sense that you can soak concrete and it doesn't go back to being mush like a chunk of adobe would. But it will wick water, so it's probably a good idea to make sure that no water can be wicking up through here. If you're doing this kind of a concrete toe-up, if you will, a footprint, we generally waterproof the top, sometimes with asphalt goop with a layer of roofing felt over it. People have used sealers, Thorough Seal, which is a concrete sealer, and painted that on, black plastic, any of a number of things, just to make sure that if there was a puddle outside and water was wicking up in the concrete, it wouldn't be against the bales. Bales don't like water. When you start laying bales, you want to start with your door frames already in place, whatever rough door frame, rough buck you have, and you start there, and you would start out here, assuming that the corner was out here somewhere, which it wasn't, it was right here. You would start at the corner also and kind of work in and take care of any fooling around you have to do, finding a longer or a shorter bale or making a custom bale. you take care of that where your two runs meet. It's sort of like driving the Golden Spike, railroad, building the railroad from out west and from out east and meeting in the middle. Just a good practice. You don't want to be fudging around at your corner, and you want these bales to be good whole bales that are up there close to the door frame. And I'm going to say close to because I'm becoming more and more convinced that I would like to have about a finger width of space between the end of that bale and the door frame. There is absolutely no need for those bales to be up against the door frame, and it can really prevent some problems by doing that. In a load-bearing building, if you compress the bales, what happens is they get longer. They get nowhere else to go. They don't get wider. If you compress them, they get longer. And so the wall actually widens slightly. And if you've pushed these bales, smashed them, kind of people want to have everything fit real tight, jam it, and you push them up there, you can start deforming the frame just by doing that. And then once you get the weight on there, you can further deform the frame. So I really recommend just spacing them out a little bit, quarter of an inch. Just leave that gap. It isn't going to do any harm. You can stuff a little loose straw in there later when you're getting ready to stucco, but it can really help you in terms of not deforming your frames. We try to lay the bales with a running bond wherever possible. If your bales are twice as long as they are wide, fortunately, that's true generally with the three-string bales. They generally are about 24 wide, 48 long. That makes a very nice situation because your joints end up being about at the halfway point of the bale below. Now you can see they're a little off here, and that is because these bales were not fully 48. They were averaging around 45 or 6. So that they had to put flakes in to fill those gaps. And that means that the running bond got off a little bit. Instead of the seam being here, it's over here. Not that big a deal.
One more thing if I could butt in, Mark.
Sure.
One of the things this picture shows, and maybe you pointed out with the dot, is that the bales aren't even the same on both sides. So you have one type of bale or the one side of the bale with a grain and all the marks on it, and then you have the other bale which has no texture. It's kind of mushed together.
This is the folded edge of the bale.
And the cut edge.
And this is the cut edge.
And you generally like to have all the cut edges on one side and the folded on the other. It makes for much easier and more uniform plastering and fooling around with the bales.
However, if you were working in Washington State with Chris Stafford, he would absolutely say that you need to alternate them, because they have found that there is a difference in compressibility between the folded side and the cut side. And so in a load-bearing structure and some load-bearing testing they did, they found that the wall started to curve when they loaded it because of that difference in the compressibility. I can't remember now which was which, but one side compressed more than the other. I've never personally found it to be any problem with these good three-string bales. They were working with more compressible two-string bales. But David's point is well taken, particularly in the sense that if I'm going to do mud plaster, adobe plaster, and I'm putting it on with no wire reinforcement, I would much rather be putting it on this cut edge, because you can push it on and it goes into the grain, and all those edges, all those straw stems are sticking out at you, and it's very much easier to get it to stick on. When you're trying to get something to stick to the folded edge of the bale without having the stucco netting reinforcement on, it gets very difficult, because this edge wants to shed. So you smash your plaster on there, even if you push it on very hard, it just pulls out the short little stems that are wanting to shed off anyway, and the plaster tends to slough off. With stucco netting, if you're doing cement-based plaster or stucco, with that stucco netting, it's it doesn't make much difference. You can get it on, onto either the cut edge or the folded edge without any great difficulty. But if I were going to be doing cement stucco on the outside with wire and mud plaster on the inside without wire, I'd put all my folded edges out and all my cut edges in.
Make any difference if you're spraying?
I would think it would make even less difference if you're spraying, because, I mean, it goes on with such velocity, and I've never been able to find anybody who was willing to spray without having stucco in it. To spray it on, you basically have to hire somebody who has the equipment. It's very expensive equipment, it's dangerous to use, and they don't want to come back later because there are problems. So they generally, in fact, to my knowledge, every time a straw bale building has had the stucco sprayed on, it has had wire. So with wire on there and with the velocity that you're putting it out of a spray gun stucco blower, it doesn't care.
Using stucco, or do you like a shotcrete mechanism or a gunite gun?
Technically, those are two different things. Gunite is not, I'm talking about cement-based plaster that is blown on where you've got a big mixer, you're mixing and putting it in a tub, basically, and then there's a mechanism that takes it out of the tub, pushes it through a long hose, and finally blows it out a nozzle. Okay? That's a stucco, that's blowing stucco on. Gunite is mixed at the nozzle. It's dry mix and water mixed at the nozzle, and it's generally fine aggregate concrete. It actually has aggregate in it, not just sand. And it's meant to be a fine aggregate concrete, very strong, with wire reinforcement, usually much heavier wire. They make swimming pools out of it, they make retaining walls, and that sort of thing. Now, people have gunite straw bale buildings. And there's a very interesting technique for creating a post and beam structure, in fact, by cutting notches in the side of the wall, the bale wall, and gunniting it. Putting some rebar in and just gunniting it. You can blow it so stiff, you don't even have to put a form board. You just blow it in.
Oh, yeah. It's really very fast, high strength on gunite. Very low moisture. And in fact, I did one test bale, just to let you know, that with the gunite, which is very high pressure, we've got excellent penetration without wire, and you probably could get away with it, but again, you might not find anybody who'd be willing to do it.
Some people have done one coat of gunite blown on, and then just a very thin color coat. I've seen it done on a big privacy wall in Tucson. Okay, we need to sort of move on here. You notice in this case there is no corner guide. There's sort of two philosophies about that. Some people say it just makes a lot of sense to have a corner guide on there. Then you can just kind of tuck your bales into that corner guide, and you know they're at the right spot. It's going to keep your wall vertical, and that's the way to do it. Other people who have seen what happens when you do corner guides and they're not very firmly attached are nervous about it. Because if you've got a corner guide there and it gets bumped and people push and try to force things and there's a bale that's not quite the right and they push a bale in over here and it pushes out on the corner guide and it moves and you don't check it and you think it's vertical, you get to the end and you take off your corner guide and your wall, your corner is not straight up and down. So if you're going to use corner guides, make sure that they're sturdy and that they're very firmly attached so that it would take great force to knock them out of plumb. And I would tend to even actually make them so they slope in just a little bit. And the reason for that is, again, with a load-bearing building, when you compress the bales, the walls lengthen. And I have never seen a load-bearing straw bale building that did not end up sloping slightly outward at the corners. They're always a little out of plumb, and it's always out. It's never in. And so there's some justification in thinking that if you would have it out of plumb inward about an inch, or 3/4 of an inch from bottom to top, that you might then, once the compression took place, you might very well end up with an absolutely vertical corner. If you start with one after the compression, it's going to be a little bit out. The other way, the way this was done, is to simply use levels attached to a good straight 2x4. You tape a level onto a straight 2x4 and you use it diligently as you're laying bales to make sure that you stay good and vertical on the bales that form the corner. These bales out here, you can push them around later. Your wall can be 6 inches out of plumb when you finish, and you can push that on. And when you fasten the roof bearing assembly to the top of the wall, it's going to hold that wall plumb. So it's not so critical that you stay absolutely plumb out in here. But it sure is on these bales that have formed the corner, because you cannot push them around. Without dismantling that corner, you're stuck with it, however it comes out. So it's worth taking great care there if you want the building to have absolutely plumb walls. Now you can fudge a little bit. If it's sticking out a little bit, you can trim with a chainsaw and get rid of it so that from a 45-degree angle it appears straight. You can do that kind of thing, but you can't make any major changing in the position of those bales. Don't use flakes that are more than probably 4 or 5 inches thick. If you've got more than that, split it into 2. Since they had used a 4-foot module in laying out the foundation for this building, and the bales were only running about 45, 46 inches, they had a lot of 4-inch gaps. There were a lot of flakes in here. But our common wisdom says that that's not really a problem structurally. You get a good flake in there, you're filling the gap, you're still pinning down through, you've got your tie down, you've got the compression of the roof load which stiffens the walls, and so it probably has very little effect structurally. The problem with not splitting up your flakes, among other things, is that if you've got a big gap here, and you put in a 12-inch mini bale or something, you really start throwing your running bond off. You start having, not much overlap here. Whereas you'd like the seam to be here, you may end up with a seam over in here somewhere. And it doesn't give you, if you're pinning, doesn't give you much to pin down through to kind of tie those two bales together. The pinning's been done with bamboo, with wooden stakes, with willow stakes, with rebar, with agave stems, just about anything you can imagine that you could use as kind of a nail. There are several different pinning systems. Using short pins and going through 2 bales at a time is a fairly common technique. It doesn't probably give you quite as much stiffness in the wall or resistance to deformation by wind, for example, as the pinning with longer pins. We often use 5-foot pins if we're working with rebar or bamboo, using 5-foot pins starting at the 4th course, and then pinning the 4th, 5th, and 6th courses on an 8-foot high wall, or the 4th, 5th, and 7th course if we're going up 7 courses. It turns out that once you get the roof weight on there, on a load-bearing structure, once you get all that roof weight on there, compressing that wall, these pins, it turns out, we know now, are basically redundant. There's more stiffness coming from the compression under that load than is provided by the pins. The Canadians did some testing recently where they they built two walls, one with pins, one without. They compressed it as if there was roof load on, and they tested it for sort of what's called out of plane lateral, as if you're pushing, as if your wind is pushing against the wall at right angles to the wall. Both walls performed absolutely the same. So it's clear that the dominant, we've gone beyond whatever that might have done because of the compression. So it turns out, in that sense, that these pins really then are only functioning to stiffen the wall during construction, at least as far as wind blowing against the wall. But the question still remains, what about a force at the end of the wall pushing parallel with the wall? And that hasn't been tested. The Canadians did not test that, which was, I think, a real, they should. They left that out, because now we still don't really know whether the pins are important or not. We know that they're not important in terms of wind load at right angles to a wall, but they may still be important in terms of what's called in-plane lateral, or resisting shear, resisting the tendency for the wall to change from, a rectangle into a parallelogram, basically. So
Cal Poly has just done some in-plane shear tests, but the wall assembly was so strong they were getting the bolts were shearing that they had mounted the wall to the floor. So they got some evidence that they were quite strong, but they didn't really distinguish anything more about it.
So I think we still need to test to satisfy code people, for example, and say, look, we don't need to pin anymore. We can just stiffen the wall by little diagonal braces, temporary on the outside, stiffen the wall during construction just to keep it straight. And once we get the roof load on, there's no need for pins anymore. To be able to convince them of that, we need to test a pinned and an unpinned wall for that shear, racking shear, and see whether there's a difference. The bamboo may function differently than rebar in the sense of resisting that kind of shear. And nobody has done that kind of testing either. Still a lot of testing that needs to be done in a number of areas. Okay, when you get up to the point in a wall where you're going to add a window frame, you need to think about some waterproofing. There are three places in the wall where water is the most danger. One is down at the foundation level. The second one is at places like this where you have a horizontal surface that water might get down into the bales. The other is up at the top of the roof bearing assembly, which isn't in place in this slide. Most window frames are not built this way so that they take care of the whole width. And so this waterproofing becomes particularly important on the outside. If your windows are set back in, it means you have sort of a pretty horizontal sill on the outside. And if you're stuccoing, you better believe that the stucco is eventually going to crack, micro-cracking, or pull away from your window frame. And we really think that it's important to do some waterproofing at these window levels. In some cases, it may be important even to have the waterproofing also on the inside. Sue Mullen in her house in New Mexico had single pane windows, moisture on the inside, cold weather on the outside, and so much condensation on the windows that it was running down the windows and getting on the inside sill, and there was a crack, and the water was getting down the crack, and she started smelling mold. And so she had to, at that point, very carefully caulk all those cracks to make sure that water wasn't getting down in there. Roofing felt or grade D paper is probably not the best thing to use here. There's a material that we've started using, which is it's a bitumen product, it's B-I-T-U-M-E-N. It's called Ice and Water Shield. I'm sure there are other brands. It's a reinforced asphaltic membrane kind of stuff. It's very strong. Sometimes it's made with one side that's sticky. It doesn't do any harm with the straw bale. W.R. Grace and Company makes a product called Ice and Water Shield. Pretty readily available even in Tucson. We don't have much ice or water. But It's used in construction, and it's a very, very tough, non-tearing kind of material. Question?
Do you think that the Envirolock might work in that place, or would that be?
Envirolock is a sealer. It's a brand of, it's actually, they don't want to call it a sealer. They want to call it a water repellent, because it doesn't seal in the sense of, it doesn't block the holes. It still leaves vapor permeability in the stucco. But certainly treating the sills, the stucco, you have stucco that's more or less horizontal, and because you want to slope it as much as you can at a window opening. Treating it with something like Envirolock, which would make the stucco act like Gore-Tex. Liquid water couldn't get through into it, but it can still breathe. However, if the stucco cracked, then you'd still have, a gap that wouldn't be treated, that could conceivably allow water to get down through it. So I still think, even if I wanted to seal, that would just be, or put a water repellent on the stucco, that would be an extra layer of insurance, but I'd want that layer of insurance in there too. Yeah?
It's a belts and suspenders approach to preserving that hay or straw, I would think. The Envirolock makes me will bridge small cracks by nature. But as it pulls away from other materials used in the window, where you may need the caulking, you definitely will need some sort of a membrane underneath the sill.
Yeah.
I agree.
And it probably depends. Micro cracking, I'm sure, probably the Envirolock would help in terms of micro cracking. If you've got a major crack in the stucco where you really had a visible gap, I'm less sure that it would keep water from going into that crack. Okay, let's talk a little bit about window frames. This happens to be a load-bearing window frame. And there are two different approaches to frames. One is to make the frame itself, either a door frame or window frame, have its own built-in lintel. The lintel is just something that bridges across an opening. You have vertical sides that are holding that lintel up there, and this is usually thicker because it has weight on it and you don't want it to deform. If you have a very wide opening, these sides may also need to be constructed more like this in terms of a box to provide additional stiffness. In a small opening like this, these people felt that it was adequate. This was a load-bearing building, so there was going to be some load on top of that box, but they felt that these were going to be adequate. You can see also that they made the window frame splayed. It's wider on the inside, or beveled, we often talk about, a beveled opening. It's wider on the inside than the outside. The window will be mounted out here. The advantage of that is that in a very thick wall, if you don't do this, if you don't bevel it, as soon as you get off to either side of the window, your view is cut off. And the same thing is true in terms of solar gain. It doesn't get all the way into the room if it's cut off by the corner. And there's a diagram in Build It with Bales which I think shows that very clearly. The advantage both from the standpoint of views out and sunlight gain coming in, that there is a real advantage to broadening that opening. Sometimes people just settle for rounding here to just take the corner off, and that certainly helps some. But in a very narrow opening, you may find that you want to do a very substantial bevel like this. These bales were actually beveled, and that's one way you can do it, is to shape the bales, and there is a way to do that, to create that angle in the bales themselves. Another way to do it is to build it with carpentry. You build the frame out here, the sides of the actual frame are out here, and the window is only this big. So you basically have a space on either side, and you can angle back with carpentry then and create a triangular space which you can fill with straw. So in that case, you use the window is smaller than the opening you start with. You have a subframe within your window frame that holds the window, and then you use carpentry to create it. And again, we've got a diagram in there, the Bale's, I think, shows that pretty clearly. Indeed, I like to do, if I can, do all my openings a half a bale wide, a bale wide, a bale and a half, 2, 2 and a half, 3. I like to stay with that half bale module. It means that I can then only use full bales and half bales in the construction of the building. And I find it very easy, even if the window or the door is not exactly that width, it's very easy to subframe and take care of that, and very often you can use that extra space to create the beveled opening that you want. Okay, so in this case now we've gotten up to the point where we want to add that roof bearing assembly on the top of the wall. And by the way, this was the end of one day with a small group of people, none of whom except Steve McDonald and I had ever done straw bale before, and we hadn't done that much at that point. And it does indicate, that you can really, this part of a straw bale house goes fast. Later on it goes slow. Sometimes maddeningly slow, but this part, the wall raising, can go real quickly.
How long is that?
Oh, this is about 35 feet long, 20 by 35. It's Kate Brown's pottery studio in Rivers.
You tend to reinforce it with that kind of length, you reinforce the wall with posts or anything?
This was a low-bearing structure, so it had no vertical post, although it compressed enough in some places they didn't leave much slack. We had to, in fact, chip the foundation, which was a pumice Creek foundation. We had to chip it out to get the window frames in because they had miscalculated. So there was very little space up here, and in some cases the roof bearing assembly settled until it was resting on the window frames. That was not planned. Unfortunately, it hasn't created any problems, but they were not meant to be load bearing, and they turned out, in fact, to be somewhat load bearing. There's a great variety of roof-bearing assemblies that have been used. We have a whole page of Building with Bales of different roof-bearing assemblies going from sort of non-rigid, of which this is a very good example, 2 2x6s, one inside and one outside. So single 2x6 with little cross pieces, a ladder. People often talk about it as a ladder roof-bearing assembly. Quite flexible. You can't count on it to bridge across openings. And there are other roof-bearing assemblies which are made like boxes, and sometimes the sides are done with wooden I-beams, even rather than dimension lumber. You create a very, very rigid, non-deforming box, and in that case, it can bridge across openings, and you can do very, very light window frames or door frames underneath it.
You ever tried to do that with the steel studs or metal?
I have never personally done a metal roof bearing assembly, but Marilyn Cochran and a couple of her friends up in Montana did do an angle iron roof bearing assembly that went all the way around the building at the top and was stiff enough to serve as the lintel over the openings. I've done them out of wood. Okay, you get the roof bearing assembly on, and then you add your trusses or rafters or wooden I-beams, whatever it is that's going to hold up the roof surface. You then apply the roof decking, you get your insulation in there, and you get your ceiling material on. So you create the entire load. You want the building to compress under the entire load of the roof. So you really want to try to get all of that in place. And during that period, while you're waiting for it to compress, there are many other things you can be doing. If you're a production builder doing a straw bale subdivision, you you might not want to go load bearing, because you do have this period, 3 to 5 weeks, depending on the density of the bales and the weight of the roof, and the spans. 3 to 5 weeks during which you're waiting for those walls to compress and reach equilibrium with the roof load. But if you're just a sort of small builder with a small crew, or you're an owner builder, you've got plenty of stuff to do inside that building. Partition walls, floors, plumbing, electrical, in this case, an electrical box already attached to a stake going in. We usually drive the stakes now first and then attach the boxes after. It's a lot easier. Here's some plumbing going into an interior frame wall. Very often, straw bales are designed, and it makes sense in general to design a wall that can take as much of your plumbing as possible. You know, having a bathroom on one side, which we had here, and a kitchen on this side. So you can minimize the plumbing runs, minimize the time spent plumbing, minimize the materials for plumbing. And this insulation was just in here as a sound barrier. There's a 2x6 wall. Plumbers far prefer to work with a 2x6 frame wall than a 2x4 frame wall in terms of plumbing. It just makes it a lot easier. I don't know, code may even require that now. I'm not sure, but it sure makes sense to do it. We like to keep the plumbing away from the straw bale walls as much as possible because water is the enemy of straw. So very often people bring the pipes in under the floor and pop up then into this wall, or they come through the straw bale wall in sleeves. And you have a larger plastic pipe as a sleeve, and then you bring your water pipe through within that sleeve to hopefully give you insurance against any possible leakage.
Do you have something between that insulation and the straw bale wall, or is that just a material wall?
This is an interior frame wall at right angles to a straw bale wall that's running there.
If you had to put plumbing in a straw bale wall, what would you use in there?
Well, I'll tell you what has been used. Plastic, and then furring strips sometimes, and green board, which is the waterproof or water-resistant drywall that had the seams all sealed. Again, if possible, you just don't want the pipes, in a place where if they leak for some reason, that water would be directly against the bales. We did some, in Mom's place, we had to run some pipes along the straw bale wall, so we did them on the inside of that green board. We had plastic and furring strips and green board, and then the pipes, we ran them under the bathtub and behind the vanity. So they were inside the building. And if they ever leak, we can get at them. And they're not against the straw bale wall. We call this fine tuning, bale tweaking, and there are a number of different tools. The sledgehammer works, although it's got such a small head on it that I don't really like to use it. It tends to push individual flakes rather than move larger portions of the bale. So I prefer something like a piece of 8x8 timber cut off about 10 inches long with a handle mounted on it that you can thump with. There are a number of different sort of thumping tools that people have come up with. To do some fine tuning, get some bumps out. You forgot to straighten the bale, it was a little crooked, it got in the wall. You can do this kind of adjustment. Often it's done after the roof bearing assembly is on, rather than beforehand. You get the wall kind of stabilized, and then with the top and bottom stabilized, you can do this kind of tweaking. Good bracing on this frame. Very important. Both the windows and door frames. Brace them very strongly, because if you're doing the wall raising with unskilled people, they will tend, as I said, to push the wall, they want to push the bales against the frames. And it really is important to have them very well braced so that they stay rectangular, so that whatever you're going to fit in there will fit. Bad policy. This was before we knew better. You know, on wall raising now, I want to have a couple of crews doing nothing but taking up loose straw. Obviously, we don't make them do it all day. When we shift off, if there are kids around, small kids, they love to do that. You know, give them a push broom and some plastic bags and have them clean up. Keep that loose straw cleaned up. You won't lose tools in it. If you drop or a tool falls down or drops off your belt, drops into that stuff, you play hell finding. It's just, it slips sometimes on a slab, it's slippery. So there are just a number of reasons why it just makes sense to keep the site clean. Again, we're talking load bearing here. Once the compression has taken place, you're going to do your surfacing. Now, stucco or plaster is a generic word for me. And in building with bales, we use the word plaster. Cement-based plaster, gypsum-based plaster, earth, clay-based plaster, lime-based plaster. It's a good generic term. Stucco is usually only applied to cement-based plaster. It's usually often used sort of synonymously with cement-based plaster, which is what this is. Cement, lime, and sand. The ingredients for a typical 3-coat stucco. Going on to wire, and as David pointed out in that one slide at Sue Mullins, expanded metal lath used at outside corners, around door and window frames, anywhere where this plaster is going to come up and meet wood. And I see something missing here. What's missing? What's missing? Roofing felt. Something to waterproof that door frame. On the outside, where the stucco may be wet for long periods of time, you need to make sure that the wood is kept separated from the stucco by a waterproof membrane of some kind. Grade craft paper, it's also called grade D paper, and 2 layers of that. The code considers to be a waterproof barrier. Roofing felt can be used. Black plastic can be used probably. I don't know if it meets code or not. People have even just painted asphalt goop on the wood. It's something on the outside at least to protect the wood. And you know the stucco is not going to stick to that stuff. That paper, that plastic, that asphalt glue. Your plaster is not going to stick to it. So it's important that you use the expanded metal lath. Even if this were mud plaster, and I weren't putting stucco netting on, I would put the expanded metal lath at the corners and at the openings where stucco or where plaster is going to be coming up and meeting a material that it isn't going to stick to. This is a patch. This is sort of a demonstration patch of a material called Western 1-coat. You can do, instead of doing a 3-coat traditional plaster, this is the scratch coat, then there's a brown, what's called a brown coat to smooth things out, and then there's a thin finish coat that has the color in it. You can do these 1-coat systems. They aren't truly 1-coat because you end up usually putting a color coat over this. But you can do a single base coat and then the color coat. And it's a quicker process. It often has fiberglass, chopped fiberglass threads in it. It's also expensive, so it isn't typically used.
What's the final thickness of your application?
Well, I can answer that in 2 different ways. There are places where the plaster is probably about an inch. That's what you're aiming for, a minimum of an inch. But to get a straight wall, And particularly at places where bales meet and there are little recessions, you know, the stucco may be several inches thick, 2, 2.5, 3 possibly. So in trying to figure out volumes of material for plastering, I tell people that you probably better figure it like an average of 1.5 inches, or even 1 3/4, particularly if you can return materials you don't use, because it takes a lot of material. Now, if you use a mud and straw mixture to fill in those places where the bales meet, plug those holes, and any major differences, then your expensive, if you're using stucco, the expensive stuff has a much smoother surface to go on, and you use less of it.
So you're targeting for an inch coat, basically?
You're targeting for a minimum inch. Code calls, I think, for 7/8. It's the same thing. Yeah.
But you're not using any vertical strapping for tensioning?
We do use tie downs, and I don't think in this particular sequence, that's very interesting. In this sequence, we didn't have a picture of a tie down. In the how-to slideshow that we use in the workshops, we have slides of several different kinds of tie downs. And I appreciate you pointing that out, because we should, in this abbreviated version, we should have a tie down illustrated as well.
We had a question in the desert when we did ours, using the plastic strapping, the 1,000-pound. Would that deteriorate eventually in the heat?
I can't tell you that, because I'm not the manufacturer. I haven't done the testing. I just don't know. We generally have used the woven polyester strapping, and we feel quite confident that will be very durable over the long term if kept away from the stucco, so that there's no possibility of a line in the stucco being caustic enough to damage the thing. So that's why, and the UV. If that polyester strapping can be protected from UV and from the stucco, we feel that it will be very long-lasting. However, once you've got tons and tons of stucco hanging off your roof-bearing assembly, those tie-downs are probably, again, redundant. I'm convinced, in fact, that the only thing that tie-downs are doing for you is keeping your roof from blowing off between when you get your walls up and when you get your plaster on. Because once it's on, I just cannot believe, particularly if that plaster is keyed into the bales. I mean, you're basically talking then about having to pick the whole house up. That wind getting under the overhangs is going to pick the whole house up. I think that's extremely unlikely.
Is one of the values of the tie down for accelerated compression if you need to speed up the figure?
People have tried to use tie downs for accelerated compression. They have generally been unsuccessful. When we used to do the threaded rod tie downs up through the center of the bales, people would try to crank on the nut up at the top and try to compress. They'd end up stripping the threads, or twisting at the bottom. Gripple system, which is cable with funny little gripper things where the cable can go through in one direction but can't go back. And you have tensioners and you can really pull. I've seen people cut the cable with the tensioners and have such tension on also that the cams and the gripples were cutting the cable. There is only one system that I'm familiar with that really enables you to do that pre-stressing, to compress the walls immediately so that you can stucco immediately. And that's a Canadian system. It's not really available commercially yet. Supposedly they're going to have it available. And if there is time and interest, I could talk about it. There is that one way that I know of where you get the wall up, get your roof bearing assembly on, compress.
Spray the mud plaster on?
You can spray it on, yeah. There certainly are people, there's a Bob Barnes in Tucson, invented a machine, he called it a blow bee. And he was blowing adobe on, and he was actually blowing on, he was building adobe houses with 8-inch wide bricks, and code calls for 14 inches in Tucson on an exterior wall. And so he would build them with 8-inch blocks or 8-inch bricks and blow on 6 inches of a blow bee to make the wall 14 inches. And we found that to be less labor intensive and more economical.
Did you just
How
put
do you
it,
control cracking?
The whole subject of earth or clay-based plasters is a very complex thing. And it becomes very, very difficult to give specific answers because everybody's soil is different. People always, when they come to a workshop, and we put mud plaster on the bales, and they love it. They can just put it on by hand, smear it on the bales, and they get very excited about it. And they say, oh, okay, what's your recipe? How much soil are you using? How much sand? I can't tell them. I know, but I can't tell them because they will think they can go back and do that with their soil. So you have to experiment, basically. That's what I can say. You have to experiment with your soil or soils. In the new build with Bales, I did a much expanded plaster section because we had thought that all that information was out there, easily available in the first book, so we didn't do it. And then people kept saying, I kept looking, I looked for that material, I looked for books that would tell me how to do plastering and all that stuff, and they aren't there, or they're expensive and published in England 15 years ago, and all that stuff. So this time around, I did a lot of homework and expanded that greatly. There's a big section on clay-based plasters, and about all I can say is find it at the, find Build It with Bales #2 at the library or buy it, however you get it, and study that section, read that carefully. I think it will answer your question in the sense that it goes through the process of experimentation to finally come up with a mix of your soil and sand, probably. One thing we didn't get into in there, and I wish now that I had, it's just something that I've really learned about in the last couple of months, much more, and that is using very heavy amounts of chopped straw in earth plastics. And a lot of people now experimenting with that and going with even quite a pure clay material, not adding much sand at all or no sand, and just taking a soil that has a lot of clay in it and mixing a lot of chopped straw in it and using that as a plaster. And the Germans have been experimenting with that. Frank Andresen, a German man who's done a lot of work lately with natural plasters and light clay straw, which is the technique that David mentioned. Frank swears by some plasters that they've experimented with that have taken a lot of rain over the last few years. And with all that straw in it, it basically forms a thatch, in a sense. The clay washes off the surface, but then there are all these straws sticking out, kind of, that form like a thatch on the rest of the plastic and keep it from running down in rivulets. And again, I haven't had a chance to experiment a lot with that yet, but that is another possibility approach that we did not describe in there, and that I will probably want to describe in the next version. God forbid if we do another one. David.
Yeah, one thing I would add, and at one point I thought I was starting to learn a little bit about clay mixes and muds, and then out in our mine building, we learned otherwise. Did quite a few tests out there trying to find a good system, but clay will poison the concrete mix, but clay and lime quite often interact depending on the types of clays. You can get very strong clay-lime mixtures. So we had a beautiful clay out at this at that mine building. It was actually used for the Wedgwood china. It was one of their supplies with that beautiful white Wedgwood china. We thought, oh, this will be fabulous. We got this beautiful ceramic grade Wedgwood pure white clay. And it wouldn't stick to anything. There was nothing you could mix with that Wedgwood clay to make it stick. So we made up this huge batch of it, which was beautiful.
Clay minerals it's a huge subject in itself, clay mineralogy. And there are a lot of different clay minerals, and they act very differently. And kaolin is probably what they were working with. Very different clay than bentonite, for example. Bentonite will stick to anything. A wall, anything. And it shrinks like crazy. Kaolin is a very different beast. So it's an unsatisfactory answer in a sense, but the real truth is you really have to you have to know how to approach it, but you just have to experiment and test it. Put various mixes on bales, see if they crack, add more sand or add more straw. Hit them with a hose. And the same thing with the sealers that we're looking at. I mean, we just have to try them and test them, and we'll find out gradually what works.
Are you going to talk about mixing latex paint with that fiber, that blown fiber that we did in New Mexico?
I can. You've seen this building before in David's slides. That basically ends that sequence of sort of building a kind of step-by-step, building a load-bearing straw bale building.